Morning, sir.
Good morning,
Good
sir.
morning, sir.
So yesterday we have discussed about these things. Let me share the screen. Right. So I think we have been in operators. So we have discussed about the
Members.
and if we need to go to the identity memberships, then the identity is something like, if you have equal values, something equal values. For example, I will just discuss about this identity through this Python interpreter. Okay, right. Let me discuss about this. If I have given a is equal to 6, then a will so it is compiled and interpreted. So 6 is a value stored in some memory location, and that memory location is named after A. I'm repeating again. 6 is a value stored in a memory location. We don't know, randomly it was thrown into that. Okay. For example, you think about something. You are standing in a place and you have been given a ball. Okay, there are many buckets that are there in a room. Okay, there are many buckets that are there in a room. Each bucket is having a number. Each bucket is having a number. So bucket 1 to bucket 100 buckets are there. The whole room is filled with buckets, and you are blindfolded. And we have kept the ball in your hand and asked you to just throw it. So at max, a ball will definitely, there is no probability thing here. There is a compulsory thing here that the ball will fall in some bucket. Okay, ball will fall in some bucket. It will not land on the ground. It will fall in some bucket. Okay, fine. So you have thrown and the ball was just put in some bucket, and you don't know in which bucket the ball is. In which bucket the ball is, you don't know. Now, if I ask you to fetch for the ball, what you will do, you have to search each bucket to see where the ball is exactly, right? But you also don't know which ball is that, right? There might be some of your friends also throwing the balls. You might get confused which ball is mine, right? So in this case, if there is a small thing that I have done, like in the memory, if there is a small thing that I have done. So the next concept is data type. So I'm explaining this concept again. If your ball is attached with a tag, the tag is holding your name, right? The tag is holding your name. Imagine all our tennis balls with some color, like that yellow type of color is there, right? Lemon yellow color. If there are four friends throwing the lemon yellow ball at the same time, all are having the same colors, and you don't know which ball is yours and where your ball has gone through in which bucket. So if, for example, if you attach a tag with your name to each ball, or if you have written a name on a ball, and you just search the ball with your name, that's all, right? This is what happening in the memory also. You have 6 as ball. Okay, 6 is a value which will be equivalent to the ball. Now you are throwing 6 in some random memory location. Each memory location is considered as one byte. So one bucket is like one byte, okay, containing 8 bits. And these values are stored based on their size. Okay, generally in C programming, int occupies 4 bytes. That means 4 buckets, for example. So, regarding bytes, but we can also talk like you are throwing this 6 as a value in random memory location. Okay. So, like you are throwing your ball in the bucket, and that random memory location has some address, like your bucket has numbers, but we don't know where our value has fallen. Okay, so in this case, for example, if you are attaching your name as a tag to that ball, you will search where the tag is, in which bucket the tag is exactly, And based on the tag, you will find out your ball. In the same sense, we are throwing 6 in the memory with a tag called A. So 6 will be thrown in some random location in the RAM memory, and whenever you want to call, you just call A, because A is a tag to 6. I hope you are understanding. And you press A, the computer will search for a value which is tagged with A. Now it will return the value. Imagine the same thing. You have searched for the tag with your name, and if you have found it, that ball is yours naturally, right? Have you understood the example? How the memory works?
Yes, sir.
Right. So that is the reason why I'm giving A is equal to 6, and next I'm giving B is equal to 6. Right. Now consider this thing. Now if I say A double equal to B, what you are expecting here?
True.
True, right? Fine. Now if I am saying A is B, what you are expecting here? It's also true, right? And you see why it is true, because most probably is used from equal to differently. For example, if I say I want to find out id of A and id of B having the same. Now what I will do is I will take A is equal to 6 and B is equal to A. Let me try out what is B. B is 6 naturally. Let me try out id of A, right? And let me try out id of B. So both are having the same addresses. Most probably, instead of using double equal to find out whether they are equal or not, you might also use is. But I want to give certain condition for using these things. This is the identity one. Identity in the sense it is finding whether it is exactly this or not. Now you see here, this is what indicating it like double equal to. But most probably, if A is a different value and B is a different value, if for example you are giving A is equal to 6 and B is equal to 6, though A and B are pointing to the same value. For example, a ball is having two tags, one is your name and your friend's name, but the value and the bucket is the same. The address will be the same for both, but we use a comparison symbol like this. You will use double equal to. But for example, if this is the case, I am giving A is equal to 6 and I am telling that B is equal to A. If this is the case when really required, because on the above case we don't know that A and B are actually equal or not, right? The reason is, this time I might take B as 7 also. B as 7 also. That is the reason why I'm not saying B is equal to A, but I am telling B is equal to 6. But fortunately, A and B are having the same values. This scenario is entirely different from the scenario which I am showing here. When I said that A is equal to 6 and B is equal to A, I am perfectly calling it that B is always should be having the equal value of A. అంటే ఏ వాల్యూ అయితే ఉందో బి కూడా అదే వాల్యూ ఉండాలి, అది కంపల్సరీ అని చెప్తున్నాను నేను. దిస్ ఇస్ కంపల్సరీ హియర్. బట్ ఇన్ ద అబౌవ్ సినారియో ఇట్స్ నాట్ కంపల్సరీ, అండ్ ఫార్చునేట్లీ దే ఆర్ ఈక్వల్. This is different, right? So in this type of scenario, I always prefer to find out A is B. Then you need to find out whether it is true or false. Let me check in VS Code also what will happen, and then we will have a complete explanation. Okay. Right. I will mask this one also. I will put here. Okay. Now what I will do is I will give A is equal to 6, B is equal to 6, and I will say if, see, in Python, two things are allowed. You can also do it like this. As I said, A is equal to B. I can write it print yes, else print no. This also can be done. And you can also remove the brackets and it is also acceptable. Okay, this also is a part that you can do it. In C programming, it is compulsory that you put the brackets. In Python, whether you put the parenthesis or not is not important. Remember, I want to mention these things now. These are called parentheses. Okay, use these technical terms. These are square brackets. These are called braces. You should not say flower bracket or something. You should call them as braces. Okay. So these should be very important for you. The first one is parenthesis. These are square brackets, and these are braces. So whenever I say something like brackets, you please correct me that these are parentheses. Suddenly man bracket and vachchestundi, but it should not be correct. I should always say these are parentheses. Okay, because the reason is functions always hold parameters. Okay, p1, p2 or arguments where these parameters are bounded. So these brackets are called parentheses. Okay. So that is the reason I should always say parentheses. Even here in this case, print is a function actually. There is a big code for print. I think I have mentioned in the first few classes itself. Print is not just a statement. Print is a function which might be having 1,000 lines of code to print something onto the screen. See, for example, I said if you want to print S, as I shown you yesterday, the entire screen is divided into check boxes, right? Each check is having small, small pixels, and you need to fill all those pixels so that it looks like Y. Okay. You see here, if you can observe what is happening, uh, right? I will show it here. So, have you seen that the pixels are filled? Are you able to observe? Hello?
Sir, we can see your VS Code things.
Are you not able to see what I am zooming now? Is S not
No,
visible?
sir.
No, sir.
What I will do is I will just take a screenshot of it so that you just can visualize. Okay, right. Anyway, I will take a screenshot of it later and I will show it to you how it will be looked. Anyway, you can open your VS Code and zoom it, zoom at max, right? You can see some pixel type of formation for Y also. So if this is the case, imagine that Y should be designed on the screen, E should be designed on the screen, and S should be designed on the screen. The pixel should be filled. You imagine that print is also a very large code, but you just write it like print. So whenever somebody asks me that how many lines of code you have written, what I will do, I will say 1, 2, 3, 4, 5, 6, and along with that, the 1,000 lines, so 1,006 lines, and another 1,000 lines which I am using again. Okay, so this is anyway function, right? There is no need for me to write the 1,000 lines of code again and again. So how many lines of code, in the sense I will say that the 6 plus that 1,000 for print function, so 1,006 lines. You need to remember that. You can also find out in the internet how many lines of code will take for a print in Python. You can search and you can find out. Okay. Right. Coming back. So this is possible without parenthesis also. Now let me check another way. So A is equal to, I will say 9, and B is equal to A. And if I said if A is E, okay, I can use is. Is a identity function. The in is a membership function, and is identity, not function. I should say in is a membership operator. Is a identity operator. Identity in the sense it is checking the identity of both A and B, whether they are equal or not. Okay. In the membership, in the case yesterday we have shown you, right? This is the case that it is showing. The in is an operator which is checking whether some value is there in some list or dictionary or set or something. So whether Kranti is having a membership in the list is being checked by an operator called in. Okay. So here is checking whether A's identity is equal to the B's identity. Now if this is correct, print S, right, else print no. Now let me check in this, save it, right? And I want to execute Python 3 functions2.py. So both are showing S, right? Here, right? So now coming back, let me interchange it. Let me interchange it. I will say A is B, and here I'll say A equal to B. Let me check out what we. In the case if both are working, then we can use at any point of time. But I most probably advise the before. Both are giving S. So here, most probably in this scenario, I will always prefer to use double equal to here to check the probability of whether they are matching or not. But here, because I'm seriously giving it is compulsory, I'll just check whether A is B or not. So somebody might be getting doubts, sir. Anyway, we are giving B is equal to A. Why should we again check like this? But sometimes, even though B is equal to A is given, sometimes, there are some scenarios in competitive programming where they will give two values equal or two values different. So sometimes they will also give like this. I will tell you where the scenario comes later on. But at present, you need to learn that is an operator that identifies the two operands identities are equal or not. So I will say is, and I should put it in this, is an operator that identifies that okay, identifies whether the two operands are having same identity. Okay, right. So what are the operands here for is?
A and B.
A
And
and B are the operands. If you write A plus B, plus is the operator and A and B are operands. If you write A slash slash B slash slash, that is the integer division, is the operator and A and B are the operands. So this is what about the membership, and I want the next thing I can do is A is not B. What it might be equal to? What is that A is not B?
Exclamatory.
Set a not operator.
Yes, it can be equal to this one. It can be equal to this one. Let me check out. Save. So Python functions too. Yes. Right. In both the cases, A is equal to B. So it is false. So when it is false, you should say no. They are both equal. You cannot say they are not equal. So this is the reason we get the answer no, no. Right. It will check A not equal to B here in this case. But 6 is not equal to 6 is false, because 6 is equal to 6. Because it is false, it will not go inside this and print S, but it will directly go to else. False will always lead to else, and it prints no. Here also in this case, we are saying A is not B, but A is B actually. So you cannot say A is not B. So it is false. So false leads to else, and it prints no. So these are the identity operators. Now I want to save another thing. Right. Next we go to, I think I need to show this. Next we go to the bitwise. The bitwise. Okay. I will tell you what and how the bitwise will be done. This is the last operator that we have. Now,
sir, yesterday we stopped at membership, sir.
yeah, membership, we finished it. Maximum whatever that is required at present, we finished it. Okay. In future, anything that is required, I will tell. Right. That's why I continued with identity and bitwise. Okay. Hello.
Okay, sir.
Yeah. So now I had another operator, A and B. You see, okay, first of all, I will give different values. A is equal to 3, B is equal to 5. Okay. Now I write something like A and B. I'm getting one value. Can anybody predict why I'm getting one? If I write A plus B, I will get 8. If I get B minus A, I will get 2. If I write A minus B, I will get minus 2. But what is this A and B and why I'm getting 1?
Common factor, sir.
Mm-mm.
Factor. Divide by 1.
No, that's wrong. Any other answer? Okay, just I write something else. A or B is 7.
Sir, it's changing into binary code and it is showing the result.
That's correct. The reason you need to understand is that we have something like a truth table type of thing, and or, right? And or bit operators. We have XOR, we have everything. Okay, we have not, we have XOR. Okay, so in the sense you can write not A also, that will give you different answer. Okay, so maybe I will write not of A. So it will give you something like false or some different answer that you will get. Okay. So you can also find out why I'm writing not of A is false. I will tell you later on why it is required. But at present, I want to just tell you about what is and what is R. Let me get back to your solutions. Right. So in this case, previously we have given something like A is equal to 3, B is equal to 5. Let me take to the minimum bit that we are having. So in memory, in the ancient, even in the computer science, like in 1940s and so, when the computer was initially being launched and slowly it is being developed, they have decided something like initially they said that 7 bits is 1 byte. Slowly they have gone to 8 bits. 8 bits is 1 byte. Okay, that you need to remember. What are this bit? Bit is a small holder that holds it. I think in the initial days I have explained you how RAM works, right? Imagine a torchlight, as I told you in the initial days. Imagine a torchlight. When you switch on it, what will happen? It will continuously glow something, right? It will emit the light. It will always emit the light. So what you say in computer science language, this torch is holding a value 1. Did you understand? This torch is holding a value 1 because it is continuously emitting electricity. If electricity is on, that means some electrical power is on, it is emitting some light. So this torchlight is emitting 1. Imagine there is some other torchlight which is having off. That means it is in the off position. So it is not emitting any light in the sense there is no electricity passing. So in this case, we consider this as 0. This as 0. So this is on, this is off. So in computer science, you always need to remember, I think in the first days, in the introduction days, I have shown you how computers was invented. I think I have shown you how a German scientist Jews has actually invented a computer, and how he has designed it using his electrical telephone relays. I think you remember. How many of you remember that video I have shown you that day? Have you remembered that? Anybody? Nobody remembers it?
Yes, sir. You showed on video on YouTube. Yeah.
Yeah, in YouTube I have shown it.
Yes.
1 second, I got a message. Okay, right. So in this case, I am explaining you that there is a small device called bit in your computer. This bit is actually arranged in your RAM. So there might be millions of bits in your RAM. Bit is a device which emits electricity, If it emits electricity, then it is relying on one. If it doesn't emit anything like your touchlight, then it is said as zero. So for example, if I want to say it as 3, what I will have is, I will consider this as 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. 8 bits are there. Okay. In these 8 bits, now you need to fill it like this. It is 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7. There are total 8 bits. And imagine each bit is this device, actually. Each bit is this device. And this device is either emitting some electricity or not emitting. If it is emitting some volts of electricity, I think you all know in physics, you might have studied about volts or something, right? Some volts of electricity it is emitting, then it is turned as 1. If it is not emitting anything and it is blank now, it is not working actually now. So at present it is turned as 0. In this sense, now let me ask you. I think I have also shown you the bulb example using that Scratch programming. One bulb is off, one bulb is on. Then we have decided what might be that number. So now in this case, tell me how you represent 3.
6 zeros, 1 1.
Yes, is from 2 power 0. You tell
1
me. Yes, it is 1. Next
1,
1
all zeros.
zeros. So in the sense, in this one, which we call 1 byte. Okay, 1 byte. 8 bits is 1 byte, and in this case, the bit device is emitting an electricity, so it is turned as 1. It is emitting an electricity, so it is termed as 1. It is not emitting any electricity, so it is 0. Okay, so in this, it is the way actually the computer works, because you always imagine the computer should always be an electrical or electronics device. It doesn't know what you are writing like 0 and 1. It only knows whether I am passing the electricity or not passing the electricity. And based on that, the number is decided. That's all. It's all the logic behind it that happens. But now we leave over this thing alone for ECE candidates. But now coming to computer science, we take it as 0 and 1. So now this is the case that we have. Let us write this one. So I have 3, 0, 0, 0, 0, 0, 0, 1, 1. This is the case for 3. What is the case for 5? Can you tell me from here?
1
Imagine
0 1
as it is 1.
1,
0
It is
0, 1,
1.
all
and
zeros.
5 zeros.
All are zeros, right? And now what we are talking about this thing is that let us imagine that we are asking for AND, because I am telling A and B. Okay, A and B. Now you measure each thing. If it is one is true, if you consider this as true, let me write it like whatever you know: false, 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 true, true. This is the truth table that you will learn, right? False, 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 true, false, true. Now you tell me what happens if it is and true and true,
True.
true, true and false,
False.
False.
false and true,
False.
false,
False.
false, false. Everything is false because false and false is false. Now convert them into our numbers. Okay, uh, 0, 0, 0, 0, 0, 0, 0, and true as 1.
1.
The number that you get 1, right? For and you will get 1. Let me consider R for the same thing. You will have the same like I will write in different one for R. So false, 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 true, true. This is false, 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 true, false, true. This is A, this is B. These are the values. Now tell me for R,
True.
yes, true or true is true or false is true. False or true is
True.
true, and false or false is false. Remaining are all false. Now turn it into your bits 0, 0, 0, 0, 0, 1, 1, 1. So what is this number 1, 1, 1?
7.
So if you consider the last 2 power 0 is on, plus 2 power 1 is on, plus 2 power 2 is on. Okay, so 1, 1, 1 will be there. So 2 power 0 is 1, plus 2 power 2 is 2 power 1 is 2, plus 2 power 2 is 4. So your total number that you get is 7. So this is how you are getting these answers. I hope you understand. It's just a simple true or false table, that's all. You need to understand that A and B it gives 1 and A or B it gives 7. Okay, so this is all about the required operators that you want. So let me recap once and we shall go to the next thing. Okay. Right? So the type of operators are arithmetic. We have seen that what are the arithmetic operators? Plus, minus, asterisk, slash, integer division, and power. That is 2 stars. And assignment operators. The assignment operators start with equal to. Wherever the assignment operator in the sense something like you are throwing some value in the memory and you are tagging that value. Okay, if I said A is equal to 6, so 6 is assigned with a tag called A and thrown into the memory randomly. So from there onwards, you search that particular value with the tag called A. So that's what the assignment used for. So assignment operators start with equal to. It will be plus equal to, minus equal to, slash equal to, and asterisk equal to, the integer division equal to, the power equal to. So these are the assignment operators that you have. The next thing is comparison. Comparison is like you are comparing for true or false, whether these two values are equal or two conditions are equal. So you can go for a double equal to for comparing whether two operands are equal or not. You can go for less than equal to, less than, greater than or equal to, greater than. So, and you can also check for not equal to. So these are the comparison. And for logical, you can also go for, and or not. Okay, not also you can check. I will tell you where not will be used. Now you don't understand what is not. So you can check for two conditions. For example, A is double equal to B and B less than C. You can check two conditions, that means true or false. Okay, that you need to remember. So for example, earlier we are checking whether A is equal to B in comparison, and you are getting only one value, either true or false, whether this is equal or not. But in the logical, what we are checking is we are checking two conditions actually. So you are checking, so it is the symbol for and in C. In Python, you can write and like this, and you are saying B less than C. So it might either return true or false, it might either return true or false. Now in this case, for example, we are thinking that it is returning true and it is returning false. Now this AND operator plays a major role now. It will check T and F, that is true and false. Naturally, it will return false. So the conditions will be based on this. So this is the logical. So you have AND, OR, and you also have NOT. And the membership at present, whatever required, I have told you that we have a membership in. Okay, in. So in it checks actually whether a given value is there in a list or a dictionary and so on. So then it will proceed. The in operator can be used something like this one also. You also say I in range, right? So you are saying that the I, which is initialized with 1, the starting value, and you are checking whether this I, which is initialized with 1, is exactly there in the range or not. You are saying range 1 to 10. Okay, so every time I is compared with whether it is in the range. Let me tell with an example. So in this case, also you are saying for I in range 1 comma 10. This is what you said. What happens initially is I is initialized with 1 and it is checked whether it is in the range 1 to 10. It will be in the range 1 to 10. After doing something here, some statements, again the I will be incremented to 2, right? By default, it is always 1, increment by 1, as I told you. So I will be 2. Again, this in operator comes into existence and checks whether 2 is in range 1 to 10. Yes, it is in range. I think when I said something like you write for loop in C like this, right? Less than 10, I plus plus. So this actually checks whether your range is less than 10, right? But actually here, the in operator is coming into the field. It is actually checking whether 2 is in the range 1 to 10. That means it is checking whether 2 is having a membership in between 1 to 10. That's why we call it as membership operator. Okay, 2 is having a membership in between 1 to 10. Membership in the sense it is one of the numbers that you have in between 1 to 10. So in operator compares 2 between 1 to 10 and then if it is true then it goes inside. And like that it does. And finally when you come to 10, 10 is not in between 1 to 10 because we are talking about up to 10. So 10 is not having any membership here. That's what in decides and says that it is false and makes it come out. I think now you understand why you use in for loop. Did you understood or have you understood or shall I explain again?
Understood, sir.
Under
Yeah. So this is where the in actually plays the part. Let me go back for a recap. Right. Coming to this again. So in this case, we have something like membership, then identity, we have is and is not. Be careful that is not completely a single word. Is different from not. They are two different keywords. But if they are used in one condition, they are different. So you can use is or is not. Okay. Next one is bitwise. We have discussed about what we needed because we also have some operators like left shift and right shift, not necessarily needed now. So I want to take it later, but I only want you to understand and or, that's all in bitwise. We have many things, or you have not, you have in bitwise and you have left shift, right shift, but not everything is important for now. So I'm only talking about and or. Because if you just look into XOR also, you can understand how XOR works. XOR is also having a table like true or false. Like and or, you have also XOR XOR. You can just check out and you can find out what is the A XOR B, then you can find it out. Okay, that you learn on your own. And left shift, right shift, I will tell whenever required, because if I tell it now, you will get confused. So in the sense that you should be somewhat understand what you are doing, and then you will understand what is left shift and right shift. Okay. I think Saurat, if you have studied about C++, you understand this
Yes, sir.
for being overloaded for C out and C in, for print and scan. Right.
Yes, sir.
Okay. So these are the operators that we have. So now we shall go to the data types. So these data types can also be explained in, what we say in our lab also. So, but anyway, I'm starting it now. I want to continue it in the lab for some time, then I will give you some programs to do it. Because in the afternoon, please cooperate with me and the other instructors. The reason is I have some work in the afternoon, might be. Some ISO people are coming to certify the college. So I'm there to present something. So I might be not there for some time, but in between, I will give you some programs which you need to perform. Right.
Sir, by the time, can you please give us the logic of the programs you gave in the last class? Actually, I should not complete the second task.
What is the second task I have given?
Sir, the stars we needed to print it in X form.
Yes.
Okay. So this somebody please pick up your mic. Yeah. This
Sir,
yes.
I tried out and I got it, sir. Can I
Yes.
show?
Very
Sir,
good.
even I got it. Sir.
Even I got that.
Yes. Sir, I too, sir.
Yes, that's good. So I think I will definitely explain this in the lab part. So okay, when the lab begins itself, I will just try to explain this one. I want to first finish data types because your unit exam is in the next section itself, right? So first I will finish data types and then I will explain this particular one. Okay. Who has asked for it? Saurabh?
Sorry, yes, sir.
Okay, fine. No problem. I will definitely explain. Not only you, I think many people will not understand how to do it.
Yes,
There is
sir.
a lot of explanation that I need to give here to make you understand. I will draw the checks and I need to find out the logic for it along with you. And then we will have a discussion on that. Okay, this is the way we can understand, not just giving the code directly. Okay, I will tell you how you find out the logic and then we will write the code parallelly. Okay. So before that, let me start the data types. Can anybody tell me what could be this data type? What could be
In
the
what format are we giving the data?
Okay. In what format are you giving the data? That's fine. That is one answer. Okay. Let me.
Decides how much space we can give to a particular variable.
Okay. Well, the first answer is in what format
The data can be given.
the data is given. By the way, can anybody tell me what is data?
Collection of the values and
If A is equal to 6, what is data in these things?
6, sir.
6.
Is the data, right? If I have given some list, A is equal to 6, 7, 8, 9. What is this called?
Data set list.
Yes, 6, 7, 8, 9 is also data. That's what I always told you. When somebody asks you what is the difference between data, information, and knowledge, the data is something like his nose. See, మనం నేరస్తులను పట్టుకున్నప్పుడు ఇలా చేస్తుంటాం. Some culprits, those who are not visible. I think we ask the witness, the police ask the witness for all the features. It tells, okay, the nose is very long and his eyes are very bright and they are very, okay, bright is enough. His ears are very long. Like that, he gives some measurements, right? Combining all these things, the artist will form a face of that particular culprit, and we call this as information. And using this space, the police searches what to whom he is related and what he does and where he lives, everything. So this is called knowledge. That's what happens in our brain actually. Okay, this is the information. So if you say A is equal to 6 is the data, if this A is used in some form, A plus B whole square something, then we form it as information here. Okay, where this data is used for some calculation or some format. And if you use this entire knowledge, entire value, and you are relating it to some other values or expressions, then we form a knowledge, something like that. So it's very small example. This is not exactly, but you need to learn a lot when you come to databases and data mining. You will have a lot of information on these things. So coming to this, we know what is data now, and somebody has said in what format the data is given, and somebody has said how much space is given. So both are correct actually. These both definitions are correct. Why somebody has said how much space is also important. Uh, it's a very long thing. I should not get any disturbance, otherwise you will forget it. Shall we stop it here and go to the lab and explain later?
Yes, sir.
Okay.
Okay.
We have only 5 minutes, and if I start with what is integer itself, we will break down on the
Middle of
middle of the integer only. So I don't want any breaks here. I want to continue my topic. So I will continue it in the lab. Okay.
Okay, sir.
Okay. You can slowly migrate to the other class. Bye bye, everybody.
Thank you, sir.
Thank you.
Thank you, sir.
Bye,
Thank
sir.
you, sir.
Bye bye.